Welcome to this lesson on crystal lattice. Today, we're going to explore one of the most fundamental concepts in chemistry: how ions arrange themselves in three-dimensional space to form ionic solids. Understanding crystal lattice structure is essential for explaining the properties and behavior of ionic compounds that we encounter every day, from table salt to minerals in rocks. A crystal lattice is a three-dimensional, repeating arrangement of atoms, ions, or molecules in a crystalline solid. Imagine a pattern that extends infinitely in all three dimensions, creating a highly organized structure. This lattice has two key features. First, it forms a regular, periodic pattern that extends in all directions throughout the solid. Second, it's built from a repeating unit cell that acts as the basic building block. This unit cell repeats over and over again to construct the entire crystal structure. To understand crystal lattices in ionic compounds, we need to review the basic components. Ionic compounds consist of two types of ions. Cations are positively charged ions that form when atoms lose electrons. Anions are negatively charged ions that form when atoms gain electrons. The magic happens through electrostatic attraction. Since opposite charges attract, cations and anions pull toward each other with strong forces. This electrostatic attraction extends throughout the entire structure, holding all the ions together in a stable, organized lattice. One of the most important features of ionic crystal lattices is the alternating pattern of cations and anions. Let's look at sodium chloride, or common table salt, as our example. In this structure, sodium cations with a positive charge and chloride anions with a negative charge alternate in a three-dimensional checkerboard pattern. Each positive sodium ion is surrounded by negative chloride ions, and each negative chloride ion is surrounded by positive sodium ions. This alternating arrangement maximizes the attractive forces between oppositely charged ions while minimizing repulsion between ions of the same charge. Crystal lattices have several key characteristics that define their structure. The coordination number tells us how many nearest oppositely charged ions surround each ion in the lattice. Charge balance is crucial. The overall lattice must be electrically neutral, with total positive charges equaling total negative charges. The strong electrostatic forces don't just exist between nearest neighbors, they extend throughout the entire structure, creating a network of attractions that holds the crystal together. Finally, the lattice is built from repeating units. The same geometric pattern repeats in all three dimensions, creating the regular, predictable structure we observe in crystals. Sodium chloride is the classic example of an ionic crystal lattice. Its structure type is called face-centered cubic, abbreviated FCC in this arrangement. Ions occupy not only the corners of a cube, but also the centers of each face. The coordination number in sodium chloride is 6, meaning each ion is surrounded by 6 oppositely charged ions. The sodium cations and chloride anions alternate in a cubic pattern, creating a highly symmetrical and stable structure. This specific arrangement explains many of the physical properties we observe in table salt, from its cubic crystal shape to its high melting point. The crystal lattice structure directly determines the properties of ionic compounds. First, ionic compounds have high melting points because the strong electrostatic forces throughout the lattice require tremendous energy to break apart. Second, these compounds are hard and brittle. The rigid lattice structure resists deformation, but when enough force is applied, the crystal suddenly fractures rather than bending. Third, ionic compounds conduct electricity, but only when molten or dissolved in water. In the solid state, ions are locked in position, but when melted or dissolved, the ions become free to move and carry electrical current. Finally, many ionic compounds are soluble in polar solvents like water, where the polar molecules can surround and separate the ions from the lattice. Let's review the essential concepts. Crystal lattices are three-dimensional repeating patterns of ions that extend throughout the entire solid. These structures are held together by strong electrostatic forces of attraction between oppositely charged ions. Each ion in the lattice has a specific coordination number, which tells us how many oppositely charged neighbors surround it. Most importantly, the structure of the crystal lattice determines the physical properties of ionic compounds, including melting point, hardness, electrical conductivity, and solubility. Understanding lattice structure is essential for predicting how ionic compounds will behave under different conditions. This foundational knowledge will help you understand more complex chemistry concepts in the future.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.